This is John Black, Super Chemist. This is not an instructional video. It is just a vlog showing a video account of some chemistry experiments I have done or am learning about. I do not go over all safety concerns, so if you repeat anything in the video, you do it at your own risk. Alright, now I've done a two-part video already on how to make bromoethane or ethyl bromide. And it was the first time I made it. It was a low yield, but it was a good video because it tells how how I was thinking about the ratios of how much water, how much vodka. It's a great starting point. I mean, I think it is. But since then, I think I got like maybe a 70% or 65% yield on that first video. This video, we're going to get between 85 and about 85%. We're going to start out with vodka, 100 proof Nikolai. I'm not going to do anything to it. We're just going to use it as is. I also have 270 milliliters of sulfuric acid. It's just drain opener. I've done nothing to it. I just poured it straight out of the bottle, just like the alcohol. Now you can see I have an ice bath here. And I got a set funnel up here. My equalizing funnel is broke, so I'm going to have to use a funnel and a regular set funnel. I'm going to turn on the stirring a little bit here. I want to keep the temperature low, you know what I mean? And what I'm going to do is I'm going to pour a little bit in the set funnel. What I used to do is pour the whole thing in. And what happens is it just cools down to room temperature by the time it drips in. As you can see, I only have it filled up to here. I'm going to put this covered up with cellophane, right? Put a gum batter on it. And throw it back in the freezer. That way it stays cold. If I don't do that, it seems like the temperature, it's hard to keep it down. Then I'm going to drip this slowly. You can see it dripping. I got it stirring. And I'm going to make sure that the temperature stays down low. Inside the reaction pot's about 16 Celsius. It's been about an hour and a half. I still have 90 milliliters left. So I'm not going to worry as much about the temp anymore. I'm just going to drip it in. And because I want it to go up to room temperature anyway, I'm going to distill it after this. So once I get that 90 milliliters in, hopefully in the next half hour, I will add the sodium bromide. I'll get back with you. Alright, now there it is. I took it out of the ice bath. It's about 18 degrees Celsius. I'm going to use this pool line sodium bromide. As you can see, 99% sodium bromide, and the rest is probably water, 1%. I weighed out 210 grams. You can see right here. And I'm just going to dump it in. Now someone told me, I think it was Joe Mama, and I wanted to do it and I forgot because I'm so used to doing it this way. But they said to add the sodium bromide to the ethanol before you add the sulfuric acid. And you'll get less fumes and a couple other things. Very good. So next time I will try that. You can see it's turning it brown down there. It's over oxidizing. I'm just dumping in quick. Alright, so now I'm just going to set this up for distillation. Always remember, make sure that your flask is at least up to room temperature or close to it. You don't want to shock it with, heating it up for distillation. So anyways, I'll get back to you when I start distilling. Here's my apparatus. I'm going to heat this slowly till it at least gets to room temp more. I don't have any boiling stones. So I got a straw in there, a stir rod, a couple of them, one long one too. You can see I got a Vigorex column, comes up over to the water cooled condenser, and I have this here, and I'll put a water bath on this also, or an ice bath. It's going to take a while to get this up to temp and get it to start distilling, and I'll get back to you then. Now you can see all the red color from the bromine, the over oxidation from the sulfuric acid. See, maybe that wouldn't happen if I'd listened to Joe Mama and put the salt in first while it was nice and cool and added the sulfuric acid. Anyways, it's starting to boil very slowly. Alright, so it's starting to come over. It's boiling good. So I'm just going to distill it slow, and I'm going to keep distilling it until it goes up to about 68, 78 degrees, like a little bit under the boiling point of ethanol. This is the first time it's been this red. I've done this experiment a few times, and it's usually like a brownish. It almost looks like I'm doing nitric acid, something with NO2 gases or something like that. This time it is like red, like bromine should be. I did use a different sodium bromide than I usually do, and I used a different sulfuric acid than I usually do. And I could definitely see a difference in the color. Again, like Joe Mama said, maybe add this sodium bromide first while it's nice and cool, and that way when you add in the sulfuric acid, you know what I mean, instead of it oxidizing it to some of it to bromine, it'll be nice and cold, and maybe none of it, less will be oxidized into bromine. I'm actually bringing it over at a fast rate, faster than I should, but like I said, I already did this video once before, and I'm just showing you because I went from a 65 or 70% to an 85%, you know what I mean, 83 to 88% really. So anyways, I'll let you know when I'm done here. I'm halfway done, but I wanted you to see the steel head. See how there's little, it's like oily now. And you can see there's like a line that goes right across it, out of the way. Right to the steel head, like right to the condenser, I mean. See how there's a line here? You can see all the drops on it. That's how you want it. You want it to just barely get over this lump here. This hump or whatever, this heel. But everything above my finger right here, there's no little dots of liquid. See how it's like oily? You can see that's a 250 milliliter flask. It's halfway full. So I'm getting there. Anyways, I'll get with you when I'm done. Alright, I'm done. The still head's temperature's at like 80 degrees. I turned the heat off. It's actually still coming over a little bit. So here's what all came over. That's a 250 milliliter flask. So, anytime you make a type of hydrocarbon that isn't really that soluble in water, like diethyl ether, any kind of alkyl halide like ethyl bromide. If you make it using acid, there's 3 different washes you're going to do. It's always the same, okay? First wash, you're going to use some kind of base. That's sodium carbonate, sodium bicarbonate. If you're rich, maybe sodium hydroxide. Use a saturated solution. That way you can neutralize any of the acid that's in there. And you know, the reason why I use a carbonate or hydrogen carbonate is because it produces CO2, and you could really tell when you're shaking this up, you know, whether you're producing CO2 or not, you know what I mean? Because we'll have a lot of pressure pushing the cap off, and you open the cap off to let it bleed, you know what I mean? Let the air bleed out. I don't want to put it in there. Now I poured some of the base in here just to clean it out a little bit before I add it. I don't really ever weigh any of it out, but I just put a dab. Not too much, not too little. Then you want to cap it and shake it. I just basically turn it upside down about 3 times, 4 times, and then I let it bleed. I don't know if you could hear that, but it actually pushed the thing off. As soon as I let go of that, it came out by itself. There's so much pressure from the carbon dioxide being produced. Just turn it upside down, back. I don't really shake it. I do this at least 3 or 4 times. This is the 3rd time, right? And I'll feel less pressure by this. Less pressure will be forcing the cap off. Now it's barely anything. Basically just from evaporation from these volatile chemicals. Now I might give it a little swim, a little swirly, right? And then I put it there to rest. Now I have a hole here on this top, and this has a groove in it. I don't know if you can see it or not. See that groove going up and down right here? So I can line them up so that gives a pathway for the gases to come out so it doesn't build up pressure. You can see already you got two different spot phases. So anyways, I'm not going to show it, but I'll probably do this a 2nd time with the acid. I usually do it twice with the acid. Once with water, maybe twice. Once with saturated sodium chloride. The reason why I do the water wash, and it's always these same 3 things that I'm washing with. The water is to get first of all, any acid out that didn't come out yet, you know what I mean? Also, it will take the alcohol out. It makes the 2 layers. Some of the alcohol will go on into the, you know, the polar water. Now, I might do 2 washes of that too, you know what I mean? I mean, if you really want to be thorough, sometimes I do 1, sometimes I do 2 of each of these, but really you should do 2 bases and 2 waters. Now, the sodium chloride one time is good enough, at least in my opinion. The reason why you do the sodium chloride is because you're putting all this water in from the carbonate water, the water. So this makes the water with the sodium chloride in it so polar that it really sucks up the water, you know what I mean? And you just put all this water and you want to get as much of it out now as you can. So that is what the purpose of the sodium chloride, aqueous sodium chloride, is for. So I'm not going to show the rest of these washings or whatever. You've seen I just put a tiny bit of the polar stuff in, meaning this, the base, and so that's, you can tell it's the top layer, obviously. And plus, ethyl bromide has like a density of 1.45 or something. I mean, it's pretty high density compared to water, which is 1.